Today, we're going to look at motion graphs together, and then you'll be able to interpret some other motion graphs when you see them later on your assignment. So we're just going to look at a few motion graphs. I'm going to break it down for you a little bit. Remember that motion is a change in position measured by distance and time. Speed tells us the rate at which an object moves. Velocity tells the speed and direction of a moving object. And acceleration, which is new, it just tells us the rate of speed or direction changes. We won't really focus too much on that, okay? So distance time graphs, you'll always find the distance on the y-axis and the time on the x-axis. So time is always plotted on the y-axis, which is the bottom of the graph. The further to the right of the axis, the longer the time from the start. Distance is plotted on the y-axis, this side of the graph. The higher up the graph, the further from the start. If an object is not moving, a horizontal line is shown on a distance time graph. So time is increasing to the right, but its distance does not change. It's not moving. So we say it's at rest. You also might hear something like the word stationary. All right. If an object is moving at constant speed, it means it has the same increase in distance in a given time. So time is increasing to the right and distance is increasing with time constantly. The object moves at a constant speed. So constant speed is shown by a straight line on a graph. So here's constant speed. So I drew some other lines here. These would be not so fast, and this would be faster than the one that I highlighted. So let's look at two moving objects. Both of the lines on the graph show that each object moved the same distance, but the steeper dashed line got there before the other one. A steeper line indicates a larger distance moved in a given time. In other words, higher speed. So the steeper the line, the higher the speed. Both lines are straight, so both speeds are constant. Graphs that show acceleration look different from those that show constant speed. The line on this graph is curving upwards. This shows an increase in speed since the line is getting steeper. In other words, in a given time, the distance the object moves is changing, getting larger. It's accelerating. So here's slower, and here's faster. Turn the page here. So in summary, and I really like this graph, a distance time graph tells us how far an object has moved with time. So the steeper the graph, the faster the motion. A horizontal line means an object is not changing its position. It's not moving at all. It is at rest or stationary, okay? And a downward sloping line means the object is returning to start. This is new. You might think that this is like, oh, it's starting and then it's finishing. It's actually starting, resting, and coming back to start, okay? Because here's start, 0, and here's time, and here's distance. So it goes a distance, and then it comes back to no distance, right? So that's how that works. Now let's have a look at some examples and try a couple of these together. All right, here are 4 graphs. We have graph A, B, C, or D. I'm going to ask you to use your fingers and hold up 1, 2, 3, or 4. Okay, so I'll change this to 1, 2, 3, or 4 so that you can figure out and express yourself and tell me which one you think of the graphs that one of the runners started 10 yards further ahead of the other, and explain your answer. So one of these graphs shows one of the runners started 10 yards further ahead of the other. Which one? So here's this runner and this runner. Runner 1, runner 2, runner 3, runner 4. Here we go. Runner 1, runner 2. So let's look at distance, right? So how many of you hold up your fingers now and tell me which graph you think shows that one of the runners started 10 yards further ahead of the other? If you guessed number 1, you are correct. This runner started at 0, this runner started at 10. Both of these runners started at 10. This runner started at 0, this runner started at 20. Both of these runners started at 0. This graph here below shows one of the runners started 10 yards further ahead of the other. let's look at another one. The question is, which of the following graphs below are both runners moving at the same speed? 1, 2, 3, 4. What do you think? If you guessed this graph here, you got it, because this runner and this runner, the slopes are the same. The angles are the same, which means the speed is the same. This runner is faster than this runner because the slope is steeper. This runner is slower than this runner because the slope is less steep. This runner is slower than this runner just because of the slopes. All right, let's see how much we understand. So let's see if we can practice. If we look at some descriptions, which one of these indicates the car is stopped? A, B, C, or D? The answer is C. Number 2, the car is traveling at a constant speed. Which graph could this be? A, B, C, or D? If you guessed A, you're correct. If you guessed B, you're correct. Straight lines indicate constant speed. All right, which one indicates the speed of the car is decreasing? A, B, C, or D? The answer is D. The speed is decreasing. All right, the car is coming back. Which one? A, B, C, or D? The answer is B. We have a constant speed coming back down to distance at 0. All right, hope you understand them a little bit better. Get that notebook done. Make sure you use it when you do your assignment. Have a great day.